Hello, everybody. Welcome to our VAPALS ELCAP OSEHRA working group. It's Wednesday, the 19th of June, 2019. I'm your host, Rick Marshall. We are recording, as usual, for these calls. And today we are doing sort of a technical tour. We're going to walk through the graph store that's used for storing the VAPALS ELCAP data and show how it correlates to the fields in the HTML forms in the user interface. So for those doing, say, hypothetically, certification, or not so hypothetically, they might like to know this stuff. Also, it's one of those specialty, it's almost a black box within VAPALS. So it's one of those specialty topics that even other members of the VAPALS team might not know as well. So I thought it would be useful for us to dig in, pop the hood, and see how these pieces connect together. Linda, in her previous presentation, already gave us a top-level view with the diagrams and the discussion about how the flow of control works between the user interface and the graph store and the forms processor on the back end. But today we're actually going to open up some of the parts and walk through them and prove that they work and prove that the data goes where we say that the data goes. So let's start. I have a little, not a script here, and we'll start with, we're going to look up the same patient that we were looking at.
I still don't see the recording indicator.
It is recording. It's up on my side and with a pause button if I want to pause it. So I don't know why it's not showing up on your side, but it is being recorded. So this is Kemmer 4, Fernando 460. This is the same patient that we looked at last week. So let's go ahead and submit this patient. This brings us to the case review form, where we see the forms that currently exist for this patient, along with the reports, the notes that have been generated. So we have one theoretically complete form, one definitely incomplete form, and one note that's been generated so far. I'm not going to take us on a tour of those because that's been done in previous classes, and you know, the recordings are available. Instead, I'm just going to take us into the intake note, specifically because I want to talk a little bit about these fields. So underlying all of this is HTML and JavaScript and mumps, among other things. Those are sort of the main movers and shakers here. And so what we see before us is a presentation that's automated by JavaScript. And the HTML and JavaScript agree on some variable names to call these things under the hood. So every field that you see here has some corresponding name. We have plans to make this very systematic, but right now it's pretty systematic. It's already pretty far along in terms of having encoded names. And most of these encoded names came from version 17 from the existing LCAP software that's been run at Mount Sinai for years. We wanted to maintain backwards compatibility as much as possible, which is why this is version 18 and not version 1. We are working off the same overall database structures. So one of the keys to gluing together the front end and the back end is that underneath the text of the field names that you see inside the HTML are actual encoded field names. In the interest of nothing up my sleeve, I'm going to do something that I haven't actually done here today yet, which is I'd like to show the page source. Right, there's the page source, and I wonder if there's some way to zoom in and make that less tiny. I don't know this UI well enough to know for sure, so let's keep it brief in here then. What I'll do is I'll look for date of contact, like so, and there's the label. If we look,
it's command plus. I think you would do command plus. I think.
Yes. Thank you.
Much more helpful. Thank you.
Yeah, I think that's going to be more readable. So there's our search. We found date of contact. So this is the same field label that we see up above. And what you see in here is that out in the field definition in the input value, notice the date 6/12/2019 is the same date that we see there, right here, right? And then I want you to look at the ID and name for this field. It's SIPEDC. Right, SI is for intake form. It's most of the variables in here are going to have an SI prefix, then they're grouped within sections within the form overall, and then there's some kind of a code at the end of the name that tries, like DC is date of contact, right? So there's 3 components to this name helping us to identify it. Now, as a user, you don't have to know any of this stuff, but as a programmer and as someone who's looking in the graph store, it's important because that's the name that's used for the field internally, which means, among other things, that in a graph store format, as you're going to see, instead of doing a very indirect approach like FileMan does, where every field gets an arbitrary number that's assigned according to either some idiosyncratic schema or no schema at all, the actual code name for the field is used, and the data is not stored on some node in some piece that you have to decipher through a data dictionary. This is actually used as a subscript value to directly reach the field value. It's why the graph store is so fast and so good for use in HTML and other web-based applications, is that if you know what you're looking for, then you already know where it's stored in mumps. So I'm going to close this for the moment, but this is nothing up my sleeve, right? Now you've seen it. There's the HTML form, there's the date of contact, and there's the code name that I'm talking about. So remember that code name, SIPEDC. In fact, in order to make that easier, why don't I put here SIPEDC, right? Date of contact is SIPEDC. So this is the front end. Why don't we go to the back end and see what's happening at the same time? Like, we'd like to see that 6/12/2019 value in there. So I'm going to take us into mumps, and then I'm going to take us on a little bit of a tour of the graph store format and how it works, what all's available, and then we'll zero in on this particular form and this particular field to see that it's in there. So let's go here. This is Avocetta. This is our VAPALS ELCAP development environment, the team development environment. We generally do our work in separate personal development environments and push it through the GitHub repo to this location. So this acts as a point of integration. Starting with the development for patch 1, we're going to move to a more sophisticated use of GitHub, in which we're going to have branches that allow for the development of work in progress, and it'll have to be merged in before it's allowed to go in here. So we'll be able to test each other's work before it goes into the shared development environment. But for now, we just have to be really careful to not disturb certification. So let's be really careful. I want to start by giving you a little tour. I'm going to start right here, looking at, this is a MASH global. And this MASH global is used to store graphs. And so it's in the MASH namespace, lowercase %w is for the web, and D is the temporary namespace that we're using for GraphStore. Eventually, GraphStore data will move over into %dg for GraphStore datasets. But for now, because the GraphStore is being used primarily as an adjunct to the web, we developed it within the web's namespace. What you're seeing here is a FileMan file, sort of, right? Certainly at a top level, each of these could be thought of as if this is the root of the file, and if this is the file number, which we'll check in a moment, I'm just going to copy that, then this would be the internal entry number, and this would be the 0 node, which is the first node that's always created within any FileMan file, which means that this, as the first piece on the node, must be the .01 field. And the .01 field is the name of the graph that you want to look at. So I'm going to take a step away from the graph for a moment and go look in FileMan. What does FileMan think this looks like? If we paste, no, I don't want to paste that. I'll just put the number in, 17.040801. So 17 is the number space for the MUMPS Advanced Shell. Approved by the Database Administration Committee. The reason it's a long decimal is that MASH has a lot of kinds of data, and so we allocate these between 17 and 17.999999 among an enormous number of potential files. So 17.040801 is our graph file, and if we do 2 question marks, we're seeing the same list basically, but now sorted alphabetically, that we saw up above when we directly looked at the global. And if I pick one of these, like, I don't know, VAPALS-patients, hypothetically speaking, we're going to see it only has a single field, right? Now, that's not the only thing in the global. We're doing the same thing that the lab application does. We have a global in which some of the data in it is in FileMan format and some of the data in it is not in FileMan format. And the reason that some of it's in FileMan format is to make it easier to start with a top-level perspective on kind of what's on your system. We eventually intend graph stores and FileMan to work very closely together, so that graph stores could be used like halos around files, where they could be a loading dock. You could bring data in, you could bring data out. You could project data in a different format, like SQL format, if it wasn't stored natively that way, and also so that you could have different data sets side by side, one as the core production data in the FileMan file, and one that's in the Halo that you use for comparison. That's maybe it's from another environment, maybe it's from a backup, so that you can do comparisons. And in any case, because it's in the file's Halo, you know that it's related to the file, which is not the case right now when you store scratch data in temp or xtemp or utility or wherever you put it. It basically has no actual relationship to the file at all unless the application knows to connect the dots. This is the beginning of something new for Vista and for the MUMPS world in terms of going beyond FileMan and linking it up with this larger technology. So that's 17.04081. That's why it's under 17. That's why it's under %WD. Let's take the next step in now and say, what if we wanted, I'm going to take you on a tour of a couple of little graph stores just so that you can see some of the contents, and then we'll zero in on the one that we care about here. So 69 from up above, if we go back up here, 69 is the record number for the patient lookup graph store, right? Because it says so right here. So if we go down here and we say, well, then show us that same node, we see that node that was in the list up above. So now we could zero in a little further, and we could say, well, what if we want to look for this patient here? This is a node that I looked up in advance. So this is another one of those internal field names that we've got here, and what you're seeing here is a cross reference on the graph store, and it's cross-referenced by the name of the internal code name of the field, SAMI name, and there's our patient. And it's telling us that internal entry number 467 in the graph store has the data about the entry whose SAMI name field is equal to Kemer4 Fernando 460. So this is all sort of FileMan compatible looking, even though FileMan doesn't know all of what's in here. But that's going to change pretty quickly. You see, we're basically taking the idea of FileMan cross-references and indexes and generalizing it, making it and triple stores and quad stores have a kid that could be really productive and flexible. So what we have here, using that 467 number that we looked up, we're able to see here are all of the field values that are stored in the patient lookup. Let me remember it's patient lookup right here in the patient lookup graph store. For Kemer4 Fernando 460. And you'll see if you look at these names, some of them are not coded. They just have names like sensitive patient, but others are coded, like SI name F and SI name L and SAMI name. So what you're seeing here is the reason why MASH hasn't been released yet. We are still developing MASH. We are still maturing MASH and figuring out what our conventions and standards need to be for the initial version that other applications will be allowed to use. Just a reminder from when we did a MASH walkthrough before, there are 3 production applications right now that are relying upon MASH. One of them is the largest one, the one that's kind of have the biggest immediate impact is VAPALS ELCAP, but also the patient loader that George developed, which got certified, is also built upon this same framework, and so is Taskman 9, which is running in production in Jordan on the EHS systems. So they all have private agreements to be allowed to use this, so that as we mature the MASH framework and have to make invasive non-backward compatible changes, they're prepared to make the corresponding changes in their applications until between us we all agree we've got a good foundation that other people can rely on. But what you're seeing here is sort of a sense of the future. I imagine that in many graph stores of the future, there won't be an IEN here. Now, there has to be with people because there's not a good reliable key for people, but for any graph where you've got a reliable key that's guaranteed to be universal, you would use it directly as the subscript instead of an internal entry number. But in this case, we kind of have to because human names, how many John Smiths are there? Far too many. All right, but this is the one, this patient lookup graph was used to select the patient. Let me go back to the user interface. I'm going to go back to the home page real quick. It was used to select the patient here, right? When we put the name of the patient, well, when we started to type something like a K, and it brings up these partial matches, this is all being drawn by the patient lookup graph store. So if I go to, the fact that I can pick this entry off of here and it knows about it, that's because of this patient lookup graph. So we were using it that far, but it's not. If you look in here at the data that we've got, this is not the complete set of data that's associated with the intake form. If we go to the intake form, And we look at this date of contact, and we remember that that field was called SIPEDC internally. If we look for SIPEDC here, we're not going to find it. This is not the graph that contains the intake form data for this patient, right? We have multiple graphs that we use for different purposes. So I need a value out of here in order to find that graph in its other location. So I'm going to type it in here, and that is 62. So 62 is, sort of corresponds to that's the entry in the Vista patient file, and that's an important number for us for cross-linking with our Vista database. And we use it to generate our study IDs. The study IDs are the primary patient identifier we use internally within the SAMI application, the VAPALS ELCAP application. And that study ID has a prefix for now, for us, while we're in certification, of 3 X's and then a certain number of zeros and then the 62 at the end. So you're going to see that in a moment, that we use that internally as a key value. So I had to look up that DFN. So let me just look at a couple of others real quick. If you were hunting about, you might see some graphs in here and think, well, I wonder if that's the one I'm interested in, like LCAP patients, right? Our application is called VAPALS ELCAP. You're looking for the data for patients. It's LCAP patients. You might understandably think, oh, graph store 2, that's my graph store. And rather than tell you that it isn't, I'm going to show you, you can look for yourself. You can say, well, okay, let's confirm, yes, that's our LCAP patients graph store. And you can say, well, then, do I have Chemer4 Fernando 460 in this LCAP patients graph? And voila, we get nothing, right? And if we try to use the 467 lookup number that we had in the patient lookup graph, we find that doesn't match either. So we're not dynamed across with the same IEN. We don't have the same name, and that's because there's not much in LCAP patients. Just because a graph store name looks promising doesn't mean, well, you know this from Vista, right? I mean, how many blood pressure fields are there? How do you know which one is the one you're looking for? You have to learn. Right? You have to look for the connections. So that's what we're doing. We're walking through and teaching. I'm going to show you one more other graph store that isn't the one that we're looking for, and then we'll look at the one that we are looking for. So that's form fields intake. All right. Remember, I talked about the fact that there are data dictionaries in the graph store. Just like FileMan has data dictionaries, the graph store also has data dictionaries. And so here at the bottom, these are some cross references, but I'm going to scroll back up above them, above the B cross reference, and take us into here we go. So if I wanted to find SIPEDC, right, our date of contact, I would look in here and I see that it's field number 28, just like in a standard FileMan cross-reference. So now I'm going to go up and look for 28. Pardon the scrolling here. And here we go. And here is the current generation data dictionary for the graph store for this field. Now there's a lot more information that's stored in a FileMan data dictionary. This is not yet a superset of FileMan, but it's growing. And the kinds of information that we have here right now are focused less on what does FileMan currently do, and they're focused more on what do our forms and our user interface do. Because, how do we know that the label for SIPEDC is date of contact? Well, because we say so right here, it's in the label position. And how do we know that it's text? Because it says it's text. So this is the data that corresponds to what's in the HTML. And what we are working on right now, we're starting by developing the UI manually with our expert Dom, who's gracefully created us a beautiful responsive UIs that will react to whether they're on a on an iPhone or an iPad or a laptop or what have you, and is using his experience developing for other projects. And that's fine. And then on the back end, we connect the dots. But eventually what we want to get to is where Dom's wisdom gets baked into forms generators that could read sufficiently sophisticated data dictionary and generate a form from them. We want to turn it around and go the other direction eventually. So this is not just useful information for you as certifiers to look at a field and understand what's in it, but it's also again another pointer towards the future and where we're going with these user interfaces. So I will, having established where the DDs are, which you can now look at to your heart's content whenever you feel like, we are going to move on and actually look at the graph store that has the data for our form. So what we, instead of having a separate graph for every form, we have a single universal graph that has all of the forms filled out on all of the dates for all of the patients. And this is the VAPALS patients graph. This is for Joe and Joel and Sam and others who are certifying. This is the main graph that powers the VAPALS ELCAP application. It's under this root right here. So let's take a peek. Don't take my word for it. What we need to build ourselves is a little key here. As you may recall, we had that DFN value of 62, which I'm just going to go ahead and set in a local variable just for fun. And so what the key that we're going to use to look up the patient within this graph store has this structure. Now, at some place like Phoenix, this XXX would be replaced with Phoenix's 3-letter site designation, which is either PHO or PHX. I can never remember. I think it's PHO. And then we've got this 5-digit DFN. Now, as you'll know, plenty of VA Vista sites have longer DFNs than that. And we'll come back to that. But right now, for certification and development, we don't need any more than 100,000. So this serves us well. So armed with that, we're now in a position where we can say, well, let's actually look at all the forms for this patient, right? And what we find is that really there's this one, right? We've really just filled out this one significantly for this patient. And it's SI form, which is a code for I is for intake, and of course form is for form, and then the date that we did it, which was 1 week ago today, when you guys were first doing your walkthrough of the Connect the Dots presentation. So this looks like the right form. This satisfies our information. So how would we see the information that's in here? All the fields that are stored for this record? Well, you can say, again, we're just using the patient as a key, and we're using the form and date as a key, and then we're just saying show us everything else. So this is, again, very close to FileMan cross-reference format rather than FileMan upright file format. And when I hit return, you'll see that that is indeed the case, that the internal code names for the fields are being used as the final subscript, and then the value that's stored in that field is the value of the node. So if we go to SIPEDC, we can see that 6/12/2019 value, which is the exact same value we saw over here in the user interface. If we want to find 609 Jamie Rhodes for the preferred address, well, there it is, SIPSA, right? What about the zip code of 01801? There it is. And if we weren't 100% sure, we would go back to that other graph that we were looking at that had the data dictionaries. It would tell us, yes, indeed, SIPZ is the field name that corresponds to the label zip, right? These are linked together through that data dictionary. So this is our data and where it's stored, right? So far, so good. And then if we wanted to get a look at all the graph data, just confirming, we could use the star annotation right after the patient designation, the study ID, and we would see all of the graphs for all of the forms that are in here. And what we find if we scroll back, I was under the impression that there is in fact another form. This is all SI form. Aha, there is another form, CE form, right? Because we have a partially filled out CT evaluation form, and that's the data that's so far been stored for that form, which was done on that date, last week when we looked at it. So my assertion is that what you're looking at is the actual data store for the user interface for the application that we're that we're messing with. But how do you know that that's true? Well, the only way that you know that that's true is if we change the data here and our change shows up over there. So suppose it's not 609 Jamie Rhodes. Suppose it's 612 Jamie Rhodes. We had a typo, right? I'll come back and fix this later. But just for the moment, 612 Jamie Rhodes. And I say submit, right? And he's going to validate the data. And, you know, the validation is going to say 609, 612 doesn't make a difference to me, right? He doesn't have the post office database. He can't look and see that, in fact, there is no 612. It just sounds legitimate to him. So he does that, and he generates the new note with the 612 Jamie Rhodes instead of 609 Jamie Rhodes, which I could then copy to the clipboard and then paste into my CPRS form if I were filling out CPRS. But what I want to do is go back here and say, so this node right here is the one that's storing the SIPSA field, right, which was the street address field. So what happens if I well, I just need to write it, really. And what I find is it's now 612 Jamie Rhodes, right? And so if it turns out, oh my goodness, what have I done? Actually, it was 609. I was thinking of a different patient. Well, you know, again, round trip it. Let's 609 this, right? Now it's back to 609 Jamie Rhodes. I submit. It generates. It's gonna generate the, oh, and look at the change log at the bottom. You see how it knows it changed the preferred address from 609 to 612. And now it will have made an entry saying, oh, and then he changed it back because he's an idiot and he can't remember which address it is. 609 Jamie Rhodes, and again, down here on the back end, it's now back to 609 Jamie Rhodes. So this basically proves, unless I've got Alexis over here on the keyboard secretly manually changing the graph as fast as we're changing the UI, you might be inclined to believe me that that those fields on the UI do in fact correspond directly to these fields in the graph store, just like I assert they do. So this is the first half of today's presentation. I'm going to pause here for questions before I go on. And I won't go on for the full hour, but I want to show you a little bit about some of the internal tools that we use for managing the graph store. Not because you should call those things yourselves in any applications, right? Remember, MASH is still a private subscription. So, but in your own screw around environments where you're playing or certifying or doing whatever you want, I can't stop you from playing with these tools and trying out things in the graph store. And it's one good way to learn about this stuff. So I'll show you some of that stuff after the Q&A. So let's pause for Q&A and see if who wants to ask me a question about the graph store or about the data that we're storing for VAPALS ELCAP.
So what is your advantage in putting it into a graph store as opposed to just putting it into a global, FileMan Global?
Graph stores are much faster. To start with, the fact that the code name of the field is the key in the index that leads directly to the value means that we are not constantly hopping over to a data dictionary and trying to figure out where we put stuff and then building an indirect reference in. If you know what the data is you're looking for, you basically know where it's stored. That's one of the reasons that we're doing it. Another is that the fields that we were storing on all these forms has been under very rapid development for 2 years, which is why we're only going into certification now. The constant barrage of, we've changed our mind, actually, we'd like to do this thing over there. And that's legit. That's the relationship you want to have with your medical experts. As they come up with better ideas, you want to be able to morph the code to follow along. And it is much faster and easier for us to just change where we're putting stuff in the graph store than it would be to go back and manually redo a data dictionary. There will come a time when that's not the case. We have plans for the future to give us the ability to generate FileMan data dictionaries out of graph store data dictionaries, and to generate at least the first version of the graph store data dictionary out of the form data dictionary and things like that. So there's some automation that's going to come along that's going to change things. And we'll do that after certain conditions in the Vista community have changed. But for the moment, our focus was on rapid development and high-speed access of the data, for which the graph store is really optimized. Good question. Other questions, comments, concerns about the graph store and the VAPALS ELCAP data and where it's stored? Okay. Well, if something occurs to you, you know where to find us. And for the rest of this call, we're still here, and you can still ping us with questions. I'll check in again after a few minutes of we're gonna play around a little bit now with some of the tools. So on the back end, how do we access things? This is a little more filling in some technical details on the presentation from last week. When we draw an arrow on a form and assert that this thing goes over there and this data is fetched from there, I want to do the nothing up my sleeve this week and show you that in fact that is the case. So internally, we have a couple different ways of referring to forms, some kind of less abbreviated and more abbreviated. One of our less abbreviated ways is this, which is saying that this is the VAPALS application, and there is an intake form that was put together on this date. That's a piece of information that we can use internally. You've seen the study IDs, so there's a study ID, and another thing we generate is the key, which is a shorter form of the form ID, which peels off the fact that it's in VAPALS. Assuming that you're working in a VAPALS application, you probably know that it's in VAPALS. You don't need that. And as you may recall from here, from the graph store, this doesn't store the VAPALS on the front to tell us that it's there. So this entire graph 23 belongs to VAPALS. So we don't need that we don't need to use the prefix internally in our subscripts. So we leave it off. So that's our key. And armed with these values, this is a private program interface, a PPI. I'm gonna show it to you in a sec. But you could write this line of code, and I guess I'll just put that in toad vals. Or actually, let's namespace it KBAF, which is my hard hats namespace, KBAF vals. And if I Z-write KBAF vals, I have all the fields out of the graph store, including 609 Jamie Rhodes, including 06/12/2019, and all the rest of the data. Now, what you're seeing here, what's actually occurred is that, and this is one of the things I love about the graph store, is that we want the fields not packed together, separated by up arrows the way they would be in FileMan. We want them out where we can get at them. Every field on its own node, completely accessible, ready to be edited, or ready to be transformed into JSON or XML or whatever we want. What we've created here is sort of with the graph store is a loading dock format, a sort of a lingua franca translation format from which it's very easy to put it into some other structure because the data is it's together under a subtree, but it's been fanned out so that every field is separated. And because at the moment that's the native format that we're using for this application, it means that when we say we want to get some values for a form, for this patient, not only do we do it with a single call, but internally, once it sort of sorts out what it's doing, it does it with a single command. It's really a merge command. The mumps merge command is ideally suited for this sort of activity. So if I were to, for example, let me just capture this root right here. And why don't I set my root equal to that? And what I should do is I should dollar name that. So dollar name of that, like so. Oop, I'm missing a parenthesis, like so, right? Write my root. Nothing up my sleeve. That's the value that's there. Of course, with mumps in direction, it's very easy for me to do something like then merge Alexis equal to @myRoot and zwrite Alexis, right? And there's the data. This is an exact copy of what we were looking at before. So the point is, in this format with a single command, we can move our entire graph store tree from place to place. Now, you can do that more or less with a FileMan subtree as well, except that as you're moving around, it's optimized for compression and for taking up as little space as possible. It's not optimized for having the easiest possible access to every field. So this is one of the tools that we use internally. Another thing that I want to show you to help demystify is the HTML. Right? So one of the things that we talk about is that the way that the round trip works, when you make a request in the user interface to look at a form, the request comes into the MWeb server. who routes it off to the service that we've set up to receive VAPALS requests, and it has to figure out where's the basic raw HTML. And it needs to load in the raw HTML, traverse it one line at a time, looking for the field values, and then it wants to stuff the field values from the graph store into those locations. Now, that's a bit of arm waving the way that I've said it, so I'm going to demystify it. So we have a function here in our %wf mform library called getTemplate, which will tell us the name of the HTML form that corresponds to our form name, right? So if we know that it's VAPALS and we know that it's the intake form and we know the date, then we can ask mform to tell us what's the name of the HTML, the raw HTML that's gonna that we could then process to put the field values into. So there it is. That's the name, and armed with that, we can then say, well, I want a copy of that, and we do that by calling the graph store. The graph store interface has a get this, and it has now, what it's done is it's taken the intake. It's taken the intake.html. It's looked up where it is in Unix and reached out and grabbed a copy of it and loaded it into this local array zhtml. So if I zwrite zhtml, I now have the HTML, right, for the intake form. And if I scroll up in here, I can find variable names like SICE chart, right? Let's see, what do we have up here? Zip code, right? We have, this is, if you know HTML, you know what you're looking at. But the point is, we have all these bits. We have all these bits that corresponds to fields in our database. Look at this one. SIPEDC. Does that ring a bell? We remember SIPEDC, right? If I write, what did I load that into? KBAF, right? KBAF. No. Let's look at the Alexis copy. Alexis of SIPEDC. Right? There's that value that's stored, just like it's stored in the graph store. So you can imagine writing a for loop that walks through this array line by line and then looks to see, is something have an ID on it or a name that suggests that it's a field? And if it does, I could reach over to my graph store array, pick up that exact same name out of there, and use a set$extract to insert it into the line. And the result of that is that I'll be replacing my raw HTML with HTML that has all the field values in it, which I can then pass back to the web server, who will then present it to the user. So this is how the connect the dots works internally. And likewise, when they finish doing their editing and they submit the form, it comes back through the mform processor. The mform processor, again, loads this thing into a local array, but now it's got all the data in it that the user just put into it. And so again, we walk through one line at a time. We search for the keywords that tell us that we're looking at a field. We look up the name of the field and the value that's stored there, and then we update our graph store to change the value for each of those names to the value that's in our completed submitted HTML. And this is internally how it works, leaving out a lot of bells and whistles and a lot of validation and robustness, but this is the general pattern of what's happening here.
So, Rick, how is this different than XLS CLT, or the way that they normally do things in HTML?
The way that who normally does things in HTML? You mean the industry?
Yeah, there's an XLSLT or something like that.
Right. So there's a reason why this sounds like an industry standard. We like industry standards. So we're trying to follow the industry standards, but we're doing it inside of MUMPS because in MUMPS is where we have all of the data. So if we could do this with a graph store, we can do it with a FileMan file as well. And we can create linkages between FileMan files and graph stores so that we can put together, we can basically take the data that's stored in a FileMan file and using the right utilities, generate a graph store from it in which all the fields are fanned out and ready to submit or ready to present in an HTML form. This is why we really wanted to build off the web server and the graph store and do all this in MUMPS, is that it gives us the ideal place to open up access to the entire Vista database, rather than using external tools that don't know anything about FileMan and don't know anything about MUMPS internals.
And one of the other main advantages is performance. If we were to, let's say, if David was to say, you must do it with XSLT, and fill in the values with XSLT, then I would need to write a MUMPS code that would generate XSLT statements, and I would need to call an external processor to do an XSLT application to the XML, to the HTML, and then it would need to load that processor and do it. It would take a long time compared to just being able to modify it and in MUMPS with the new values, etc. So and I think XSLT is mostly optimized around XML processing, not HTML processing. So those are the output of an XSLT transform is very often an HTML file, but the input is generally an XML file. To answer that specific question.
Yeah,
Thank you, George.
And from this graph store format, we can
Sure.
generate XML easily, but we don't use it much inside the VAPALS ELCAP application, other than for imports and exports, because we find XML to be very wordy, and we wanted a terser, more concise format. So when we're doing imports, exports to other systems, we tend to use JSON. Like, for example, when we were sending data back and forth with the Mount Sinai folks, we tended to use JSON for that rather than XML. But for purposes of going to our web user interface, one of our overriding architectural concerns is to have as few gratuitous layers of processing as possible. If you want to make cutting edge, rich database, rich user interface applications for the web, typically you have to learn a ridiculous number of technologies, and you do a lot of transforming the data over and over to swap it from one technology to the next on its way out to where it's going. We wanted to strip that down to the bare minimum we could get away with, which is why what we've done here is the MWeb server gives us our interface to have a web service framework. The graph store gives us our storage framework. The HTML armed with JavaScript that Dom developed gives us our templates that we just need to fill the data into, and then it's a very fast order in operation. As many fields as there are is basically as long as it takes, and the access of each of the field values, because MUMPS is built on a B tree, is just about as fast as it can get for fetching the data to create the UI to send it out, but also to receive the data back from the UI and to file it in. Each of them is basically kind of order in, log in. It's about as fast as it can get. So that's what we built here. That's how it's structured and where everything's at. Good question, David. Other questions, comments, or concerns about what I've shown so far? Okay. So internally, despite the fact that there is this kind of long route to get to the data, this %WD long number, internal entry number, graph, we're going here, study ID, form ID, you don't have to be writing anything that long in your code. This is set up to allow us, because MUMPS has subscript indirection, it's set up to allow us to create fairly concise statements. So one of the things that's built into the graph store is the ability to pull up the global root for the graph as a whole, which is here. We knew that we wanted VAPALS patients, and he did the lookup to figure out it was 23 and gave us the global root back. And we can use that obviously if we want to look at a field like Sammy name here. But even this can be shortened up, because as long as we're working in the same patient for the same form submitted on the same day, we might want a more concise structure. And so, we can create a route like that. And now, if we want to access a field, it's in MUMPS. It's it's as easy. Sorry, it's as easy as that. So now our code starts to look extremely readable, and it's very insulated from the specific details of where we put this. And as we do this with our data and the way that we access it, it puts us in a position where if in a later version of MASH we want to move this graph store, or if we want to have multiple graph stores in globals all over the place that are pointed to through the graph store file, it's easy to do. It's easy to modify them without having to modify the code. The code is not specifically linked to the precise location. So this kind of gives you a hint. The percent yada routines, the percent WD routines, especially percent WD graph, the percent WF routines, they have most of the things that interact directly with the graph store. There's some of that in the SAMI routines for processing each specific form, but most of it's down here in the internals of MASH. So that's the goal, is to get to where the MUMPS Advanced Shell is doing as much of the work for your application as possible, of just kind of putting the data where it needs to go, including moving it in and out of the HTML forms and serving them up, so that your application then, whether it's VAPALS or a new version of Lab or Pharmacy or something else, doesn't have to know too much about this. And you don't find yourself having to reinvent the wheel. However fun it might be, you don't have to reinvent the wheel. You can just focus on the application logic and the medicine that you're trying to accomplish, and not worry too much about the nuts and bolts of how you create that UI. So this is the graph store. This is where the data is. Joe, Sam, you guys in particular, or do you have any specific questions for certification? I know one of the things that came up on yesterday's call and a week ago was, where is the data stored exactly? I hope that this answers that question with some clarity, but if you have any further questions, comments, or concerns, we are at your service. We're right here. You just have to come off mute. He says, where's my mute button? He said,
no, I don't have any questions. I think that was a great explanation. It does make a lot of sense, I think. I mean, I don't know the difference between the graph store being the most efficient way to go through it in the data dictionary, but you guys have seemed to converge on this, and that's good enough for us.
Okay, thanks, Joe. Sam, are you on the line? Do you have any questions? Or Joel, if you're still there? Okay, hearing none. Any open the questions to anybody else? Graph stores, web M-form. You have any questions about how any of this works for today? Or are you all content? You want the last of this hour back for other activities?
Could you at least touch on the EWD versus the M web server design decision?
Yeah, easy. It was an easy choice for us. EWD is very powerful. It does a lot more stuff. Right now we don't need any of that stuff. So we thought we would. For us, we're basically kind of not relative to the whole community, but relative to the work we've done in the past. We're sort of pioneering a little bit, moving out into the web. We've done some web stuff before, but the level of sophistication of DOMS UIs kind of goes beyond most of what we've generated for web interfaces in the past. But even so, we don't find that for this project we need the power that's with EWD, which means we also don't need the overhead. So we thought that what we would do is work with Sam's updated version. Sam and David Wixel have both did a lot of work on the M web server relative to the way that it was originally created for the virtual patient record. EHMP, which David Wixel worked on, for example, they did a lot of work on the M web server. So we wanted to find out how far could we take it, and we knew that the M web server runs closer to the metal and has a lot less overhead. We were pretty sure it would do all that we wanted, and I think what we've demonstrated on this project is that it does. And so what we get in return for using the M web server is just it's extremely efficient. There's not a lot of code involved. It does its handoff pretty efficiently and gets us right into our executing logic, which is what we want. I would not be surprised if, in some future project, or maybe even some later version of the VAPALS ELCAP, although I'm not expecting it for this one, we run up against limits on the M web server that make us reevaluate that and say, okay, it's time for EWD. But we're not there yet, and we want to ride this horse as far as it will go, because it's a pretty fast horse. Good question, David.
And we've designed the infrastructure and match so that it's pretty agnostic as to what web server you use.
Yes.
I think we could use the RGNet web server easily. I think we could use EWD pretty easily, you know, because EWD doesn't concern itself very much with how you store the data in mumps. It has some formats, but we could adapt to pretty much any web server solution that's out there, except CSP.
Yeah. Yeah, that's an excellent point, George. I should have highlighted that. Thank you for doing that. That really part of what's going on here is that we designed this infrastructure so that any point that there was a potential blind alley that we could get stuck in, we wrote the application logic or the infrastructure logic at that point to be as modular as possible, so that we could swap in a different piece of infrastructure if we needed to. Because we know there's limits to what we know now, and we know that our needs are going to change dramatically in the future. So setting the right layers of abstraction to make it possible to plug and play like that is kind of one of the most important strategic things to accomplish. And the way this is done right now, the graph store and MForm and the MWeb server and DOM's responsive UI architecture, they are almost insulated from each other. They're very close to being agnostic about the other one. They use each other across PPIs, private program interfaces, as much as or web service interfaces, in order to kind of avoid excessive entanglement, to make it possible in the future to change these decisions if we need to strategically. Great question, Dave. Thanks. All right, final questions for this call?
I'm good.
All right, well then that's a wrap. Thanks everybody. Have a great week.
See you guys.